In 4, we're asked to solve a system. So we have 3 planes here. We're hoping that they don't intersect, so that means our solution will be done. But I don't notice any scalar multiples between all 3 of my planes, much as 2 of the planes. So the choice is that maybe there's a linear combination. Numbers are kind of messy to figure that out. So we're going to solve this assuming there's a point. If it turns out there's a line, then there's a line. So let's take our first 2 equations. We'll double the whole first one. We'll times it all by 2 to make our x's the same. So 2x minus 2y, 2z is 20, and 2x, 3y. Just writing out the whole second equation here. And our x's are the same, so we can subtract. So we'll end up with negative 5y, positive 4z, and 41. Okay. Because we're assuming the point idea, we need to take 2 other equations and do double elimination. So let's take equation, this is going to be messy, right, no matter what here. Let's take equation 1, which has small numbers, and let's take equation 3 and make the x's the same, so times it by 2. So it goes x plus 4/5 y plus 1/2 z, 2/4 is 1/2, right, equals negative 1. Okay, again, our x's are the same, so we can subtract. Negative 1y minus 4/5 y comes out to negative 5/5 y. If you want to work with decimals here, I suppose you can. Nothing wrong with decimals. Z minus 1/2 makes 1/2 z, and 10 minus negative 1 is 11. Okay, so we've got our 2 equations set up for double elimination. Obviously, they're not the same right now. But if I take the second equation and I times it all by 8, not really the best number, but 8, I'll get negative 72/5 y. 8 times 1/2 is 4 z's. Kind of nice there. I got my z's to match. And 88. And the whole idea of picking the 8 was to get my z's to match. Okay. My z's are the same. I'm going to subtract them. So negative 5 minus negative 72 over 5 comes out to 47 over 5y. And 41 minus 88 makes negative 47. Well, when I cross multiply and solve this one, I end up with y having to equal negative 5. Well, that worked out much better in the end. Okay, once I've got that, let's go back to a previous equation. So I'll use this one. So negative 5y plus 4z is 41. We know what y is now, so negative 5 times negative 5. 4z is 41. So 4z is 41 minus 2 negatives make a positive, so minus 25. So 4z is 16, and z is 4. And I can go back to one of my original equations and go right back to the top one. X minus y plus z is 10. X minus y plus z is 10. So we know things now, right? We know we have minus 5 for y. We got 4 for z. So we end up with x plus 9 on this side. So x is 10 minus 9, which is 1. So we've got ourselves a point of intersection. So to answer part B, how do we interpret this? Well, it's a POI. These planes, 3 planes, are meeting at a single point. That point is 1, negative 5, and 4.